Hello, this is Mr. Wyrick. I'm here to talk to you today about lesson 12.1. Chapter 12 is going to be a little bit different. Chapter 12, if you look at the back of the book where it's talking about what it is, it's going to be about extending surface area and volume. So we're going to be dealing with three-dimensional figures. So the first thing it wants you to do is understand about different representations of three-dimensional figures. Now, the most common thing that you're going to see is kind of a transparent one with some different numbers and dimensions and stuff kind of drawn on there. But the first thing that we're going to talk about and that we're going to do is talk about isometric views. When it's an isometric view, if you remember your Latin roots, whatever from Miss Payne, Miss Kiefer's class, then you've got iso, which is same, and meter, which is measure. So an isometric view means it's the same measure. In other words, there's no perspective. Typically, when you look at things, the further away it gets, the smaller it gets. But when you draw things isometrically, you pretend like they don't do that. So if we have a rectangle and it's supposed to have a height of 2, we make that height at 2. And if it has a width of 3, we go 1, 2, 3, and here's my 3. And then we'd have a height of 2 again. And since this is a rectangular prism, we'll give it a third dimension of 4. So we'd connect across here, and it would still go up 1, 2. So it's going to look like we can see more than one side. And of course, we'd make these the same. So if this is 1, 2, 3, this is also 3, and this one back here is going to be 3. I didn't draw it very well. If this one is 4, then this is also going to be 4. This one's going to be 4, but it has to be on that diagonal. So we're going to be drawing on 30-degree diagonals. Don't worry about trying to set up your paper to do this. I will have isometric dot paper for you to work with. It's just a way to kind of understand how things are going to work together in 3 dimensions. The only other thing that's talked about in this lesson is a cross section. A cross section, and make sure you have this in your notes, is an intersection of a solid and a plane. So we have a 3-dimensional shape of some kind. It could be something like this. It could be a pyramid. It could be a cone. And conic sections are something that's going to come back later. It's an intersection of a cone and a plane and the different shapes that can make. For now, we'll take a look at this. This would be a sphere. It's a tennis ball, so it's a sphere in 3 dimensions. It's a circle in all directions. So it makes it kind of easy. If we're talking about a cross section, if we had a plane that went down through any point on this, the intersection of that plane and this solid figure would be a circle, no matter how we do it. If you have played the Wii, if you played the Wii when you were a kid and you had the Wii Sports Resort and it had that speed slice game where you had to hack down with the sword through the different shapes, that's essentially what's going on. If you hack down through this in a straight line, you would have a circle there and you'd be able to see that split apart in 3D. So you have to imagine what that would look like split apart. The only stuff on here is the isometric dot paper, the isometric views. You're making sketches, and then of course the cross sections of 3-dimensional figures. So we are going to work problems 8 through, let's see how far this goes and how much I want you to do here on the second page. We'll say 36. Problems 8 through 36 for this lesson. And that'll be a good way to start out for chapter 12. If you have questions over this, you don't really understand it, you have difficulty with this, you can't picture things very well in 3D, make sure you bring that to my attention, ask some questions about it, and I'll try to go over it in a way that makes sense during class. We'll see you then.